So let's take a look at inequalities in two variables. So how do we graph such an inequality? So if we have an inequality, the first thing that we do is graph an equation. And that equation will be the corresponding equation to our inequality. So we'll change any less thans or greater thans or less than or equal to's or greater than or equal to's to equal signs. We'll graph those equations, but as dashed lines if we do not allow equality, and we'll do a solid curve if we allow equalities. Now, once you do that, you have divided up your plane into two regions. And so we have to decide which region are we going to shade. To make that determination, we choose a test point in one of the regions. That test point will either make our inequality true or false. And we know that we're going to shade the true side. So let's take a look at an example that might make it more clear. So let's look at x squared minus y equals 3. And because this has an equal bar on it, it's greater than or equal to, we're going to make this a solid curve when we graph it. So negative y equals negative x squared plus 3 if we subtract x squared from both sides. Now let's divide both sides by negative 1. This is a parabola, and it opens up, and its vertex is at 0, negative 3. So you remember your 3 guide points. We're just moving those 3 guide points down 3 units and graphing. Now, let's pick a test point. And the key thing about the test point is it cannot be on the curve. So let's choose 0, 0. Notice 0, 0 is there. It's not on the curve. So we're going to substitute this into the original inequality. So we have 0 squared minus 0 is bigger than or equal to 3. That 0 is bigger than or equal to 3. That's clearly false. So that means we are not going to shade on the side of our test point. We will shade outside. And so what's this mean? Anything that we've shaded would make our inequality true. So if we chose 8, 0, since that's in our shaded region, if we substitute that in, we would have 8 squared minus 0. That's bigger than or equal to 3. If we chose negative 4, 1, then likewise, that would be negative 4 squared would be 16, minus 1 would be 15, which is bigger than or equal to 3. So any point in this region would make it true. Any point in the non-shaded region would make it false. And any point on the curve would make it true because that would make it equal to 3. Let's look at the next example. If we look at x squared plus y squared equals 16, this time we're going to use a dashed line, and that's because there's no equal bar underneath the inequality. Now this is a circle, and that circle has a radius of 4 and a center of 0, 0. So if we go out from the center by 4 all the way around, we can use our dashed line, Now let's pick a test point. And again, we can use 0, 0 because that's not on the circle. You could have chosen any point as long as it's not on that boundary. So 0, 0 plugged in would be x squared plus y squared is greater than 16. So 0 squared plus 0 squared is 0. Is 0 greater than 16? No. So that means we shade outside of the circle. That's on the opposite side of the test point. So again, any point in the shaded region would make our inequality true. So if we chose, say, 6, 6, 6 squared plus 6 squared would be 72, and that's bigger than 16.